Okay, so today we are going to be solving radical equations. We did this before we left for spring break, but it's just going to be a little review. So, step one. First thing that we need to do is isolate a radical on one side. Okay, so if you look at this problem, we only have one radical right here, so we're going to isolate this. So our first step is we need to get rid of this minus 4. Okay, so we're going to go plus 4, plus 4. All right, so that leaves us with 2 square roots of 4x plus 8 is equal to 12. But our radical is still not by itself. We need to get rid of this 2, so I'm going to divide on both sides. All right, so that leaves me with the square root of 4x plus 8 is equal to 6. All right, so now our radical is by itself, and we can move on to step 2. Okay, so if you think back, step 2 is to raise both sides to the power of the index. Okay, raise to the power of the index. All right, now if you think square root, our index is 2, so we're going to raise both sides to the power of 2. 2, 2. So that's going to eliminate our square root over here, our radical, and it's going to leave us with 4x plus 8 is equal to 6 squared, that's 36. All right, so that's step 2, raise both sides to the power of the index. Step 3 is to solve. Okay, so now we're just going to solve this like any other equation. So step 3, we're going to subtract 8 minus 8 minus 8. So 4x is equal to 28. All right, then I'm going to divide by 4, and x is equal to 7. However, we are not done because you always have to check to make sure you don't have any extraneous solutions. So our last step is we're going to take this x equals 7 and we're going to plug it back into that original equation to check and make sure it's correct. Okay, so I'm just going to go to the next slide to do that. Okay, so I'm going to take my original equation, 2 times the square root of 4 times, but instead of x, I'm going to take that 7 that we found and I'm going to plug it in. So 4 times 7 plus 8, and we want the square root of all of that, minus 4 equals 8. All right, so let's simplify. 4 times 7, that's 28. So we have the square root of 28 plus 8 minus 4. All right, then the square root of 28 plus 8, that gives me 36. So I have the square root of 36, 2 times the square root of 36, minus 4 equal to 8. And I'm going to simplify this some more. So the square root of 36, that's 6. So we have 2 times 6 minus 4 equal to 8. 2 times 6, that's 12. 12 minus 4. 12 minus 4 is 8. 8 equals 8. So it checks out. It is a solution. Okay, so x equals 7. Done. All right, we're just going to do one more example. All right, so I'm going to go to the next slide again. We're going to do the square root of 3x plus 1 is equal to the square root of 5x minus 1. Now notice this time the minus 1 is outside of our radical, so we got to be careful. All right, so step 1, isolate the radical on one side. You notice we have a radical by itself right here. Step 1 is already done for us. So we move on to step 2. Step 2 is to raise both sides to the power of the index. Again, our index here is 2, so I'm going to raise both sides to the power of 2. All right, now be careful when you do this. You have to take this whole side over here to the power of 2. All right, so what that's going to look like, your radical and your square, they're going to cancel out. So you're going to have 3x plus 1. But this is going to give us the square root of 5x, minus 1, times the square root of 5x minus 1. And then we're going to have to FOIL or box this. Okay, so that's what I'm going to do now. I'm going to FOIL this. So I have 3x plus 1 is equal to square root of 5x times the square root of 5x. That's going to leave me with 5x. All right, outside. Square root of 5x times negative 1. That's just going to leave me with the negative square root of 5x. Then inside, negative 1 times the square root of 5x. Negative square root of 5x again. And then last, -1 times -1. That's going to give me a +1. All right, then I'm just going to combine my like terms, okay? So I have 3x plus 1 is equal to 5x minus 2 square roots of 5x plus 1. All right. Now, again, I have another radical, so I need to isolate this radical again. So that's what I'm going to work on now. To get rid of this 5x, I'm going to go minus 5x. To get rid of this 1, I'm going to go minus 1. And I'm just going to do that in one step. So I have minus 5x minus 1. All right, 3x minus 5x, that leaves me with a negative 2x. My 1's cancel, so I have negative 2x is equal to negative 2 times the square root of 5x. Okay, so again, I'm isolating this radical right here, so I need to get rid of this negative 2, so I'm going to divide by negative 2. All right, so x is equal to the square root of 5x. So now that we have this radical by itself, again, we need to raise it to the power of the index. Now I'm just going to go to the next page because I'm running out of room here. So let me change colors. X equals the square root of 5x. And I'll just verify real quick. X equals the square root of 5x. Perfect. And I'm going to square both sides. Square, square. All right, so that gives me x squared equals 5x. All right, now if you notice, we have x squared. That means that this is a quadratic. Since it's a quadratic, we have to get one side equal to 0. So I'm just going to get this side over here equal to 0 by subtracting 5x on both sides. So minus 5x minus 5x. So I have x squared minus 5x equal to 0. Now that it's equal to 0, I can solve the quadratic. I'm going to try by factoring. So if I look at it, I can take an x out of both of these. So that's what I'm going to do. I'm going to take an x out, and that's going to leave me with x minus 5. Now that it's factored, I can set both of those factors equal to 0. So x equal to 0, x minus 5 equal to 0. And then I solve both. This one, already solved, x equals 0. This one over here, I just go plus 5, x equals 5. It's solved. However, I'm not done. Okay, remember, you always have to check, make sure you don't have any extraneous solutions. So now I'm going to take both of those solutions, 0 and 5, and I'm going to plug them back into that original equation to check. Okay, so I'm going to go to the next slide. I'm going to put my original equation up here just so I remember. Square root of 3x plus 1 equal to the square root of 5x minus 1. All right, so think back, 0, 5. All right, I'm going to plug both of those in. So square root of 3 times 0 plus 1 equal to the square root of 5 times 0 minus 1. So 3 times 0, that gives me 0 plus 1. All right, and over here, the square root of 5 times 0, that gives me 0 minus 1. 0 plus 1, that's 1. So I have the square root of 1 is equal to square root of 0 is 0 minus 1. Square root of 1 is 1. 0 minus 1, negative 1. 1 is not equal to negative 1. So 0 is not a solution. It's an extraneous solution. So now we need to check 5. Okay, again, we're checking both 0 and 5. So I'm going to check 5 now. I'm going to plug in 5. So I have 3 times 5 plus 1 equal to 5 times 5 minus 1. All right, so 3 times 5, that gives me 15. 15 plus 1. All right, 5 times 5, that gives me 25 minus 1. Okay, so 15 plus 1, that's the square root of 16. Square root of 25 is 5, so we have 5 minus 1. And we just simplify one more time. The square root of 16 is 4. And 5 minus 1 is also 4. 4 equals 4, so it checks out. So the only solution that we actually have is x equals 5. Okay? So you're done. Those are your 4 steps. Isolate the radical, raise both sides to the power of the index, solve, and then check for your extraneous solutions. There is one more thing I want to mention. I want you to keep in mind, if you have something like x minus 3 to the power of 1/3. Remember that this can be converted into a radical. All right. Remember, your denominator is going to become your index. So this would actually become, let me change my color, sorry, the third root of x minus 3, and technically x minus 3 is taken to the power of 1, which is just x minus 3. Okay, so your numerator becomes your exponent on the inside, your denominator becomes your index, and you are done.